We are currently working on our one variable inequalities, solving and graphing. We are moving on to the compound inequalities, which means we're dealing with the ones with the ands and the ors in them. Starting with number 9, we got a problem with an and. Let's take a quick second. Look at what and means. And means that the answers we get, or the solutions, must work for both of the equations that are given. As far as the graph goes, we are generally looking for the overlap in the answers. So we want the numbers that work for both equations. Since they don't give us a lot of space to work on, I'm going to rewrite the equations underneath. So we got a little room to work with. Solving the equation on the left, we're going to subtract that 6. And we're going to end up with p is less than or equal to 4. Solving the equation on the right, since it's p divided by 2, to solve it, we're going to multiply by 2. If we do it to one side, obviously we've got to do it to the other. So algebraically, we're looking for p is less than or equal to 4 and p is greater than negative 4. On the number line on the graph, for the p is less than or equal to 4, the equal part means we're going to have a closed circle, and we're going to be looking for the numbers to the left. On the right, p is greater than negative 4. The fact that this does not have an equal sign means we got an open circle. Greater than the negative 4 means we're going to the right. And if you remember, we're looking for the stuff that's overlapping, so we're basically looking for the stuff in between the two numbers. So all the numbers greater than negative 4 and less than or equal to a positive 4 will work for both equations. Moving on to number 10. Number 10 is an OR problem, which means we can, any answer we get just needs to work for either equation. Basically, we're going to keep everything. Some people say the answers on these end up looking like whiskers. Similar to the last one, I'm going to take a second to rewrite this so that we got some space to work. Equation on the left, since it's b divided by 4, we're going to multiply by 4 to solve. So we should end up with b is greater than 0. On the right, once again, we're dividing, this time by 5, so to solve, we do the opposite, multiply by the 5. And we should end up with b is less than or equal to negative 10. As far as the graph goes, we got b is greater than 0 on the left, so we should have an open circle, and we should be going to the right. B is less than or equal to negative 10. We got the equal to sign, so closed circle. Less than or equal means we're going to the left. Some people refer to these as whiskers because we're keeping everything. They kind of go outwards. Throwing in a couple bonus questions here, which are not on the note sheet. I wanted to take a look at some weird cases. With any luck, we will not do these, give you these types of problems during the class, but you probably ought to be aware they exist. All right, for the first bonus question, notice we're doing an and, so we're going to look for the overlap stuff. Now, in solving this one, on the left, we're going to add 1. So we should get n is greater than 8. On the right side, we're subtracting the 3. And we're looking for the numbers that are going to be greater than 8 and less than 2. So greater than 8 out here and going to the right. Less than 2, open circle there going to the left. Remember, with this being an and, we want the overlap, we want the stuff in the middle. Since there is no overlap, there are no numbers that are bigger than 8 and less than 2, this would be a no solution case because there are no answers, no numbers that work for both the left equation and the right equation. On bonus question number 2, we're dealing with an or. If we add 3 here on the left, we should get n is less than 4. On the right, we subtract the 2. And we should get n is greater than -3. I'm going to graph these in different colors just to help us out here for a second. So if the n is less than 4, that number's going to the left. But the n is greater than -3, got the open circle there, and we're going to the right. Extend that green one just a little bit. Notice, remember, we want to keep everything. And if we take a look, the 2 lines overlap each other, keep going on forever. So the whole answer is actually going to be the whole number line. Which means we would say that all real numbers work. Any number we pick will work for one of the equations or the other equation. So there are an infinite number of solutions in this case. Jumping to number 13, you may be sitting there going, this does not look like a compound inequality. It doesn't have an and or an or in there. This one's written a little weird in the fact that they have this middle section which is supposed to apply to both sides of the inequalities. This is a very special written case of an and equation. So what we can do is we can rewrite this out. So we say 10 is less than 8 plus x, and that same middle, 8 plus x, has to be less than 18. Now, as far as solving goes, it's nice, the steps should be similar on both cases, so we're going to subtract the 8. So we get 2 is less than x, or if we like writing it out the other way, x is greater than 2. On the right side, once again, we're going to subtract the 8. We should get x is less than 10. As far as the graphing goes, for the x is greater than 2, open circle on the 2, and we're going to the right. For the solution on the right, we got the x is less than 10, so open circle on the 10, going to the left. So the stuff in the middle between the 2 and the 10 is the overlap, the stuff that works for both equations. Now this would be an opportune time to point out there's another way that they write answers for these types of and questions. Since we're doing the stuff between the 2 and the 10, we can write it out this way, where 2 is less than x, which is less than 10. If we hop back to number 9, we can take a look at this and say that our p is between the -4 and the +4. I hope this helps. Good luck.